Alright, so here's some rules about working with vectors. So if I give you A, B, C, D, and K, and they are just real numbers, they're any numbers, and I write A and B as a vector, and I write C and D as a vector, and I want to add those vectors together, what they're saying is add the horizontal movements together and add the vertical movements together. That's it. K, if K is a scalar, we're going to make every part of the vector K times larger. So I'm just going to multiply each part of the vector by K. And if we want to subtract with vectors, if we want to do AB minus CD, this would be a scalar of -1, just to let you know. So I kind of skipped that because I thought it was obvious, but it bears repeating. U gives me this one, and then negative U, that would be a scalar of -1. Just multiply every part by -1. I don't know why they like this extra step sometimes. If I do AB minus CD, we're going to change the sign in the second vector. So we're going to do A minus C, and then we're going to do B minus D. Because remember, subtractions always just mean change the sign. So A minus C and B minus D. Vertical movement, horizontal movement, horizontal first, horizontal movement, vertical movement. Horizontal movement, vertical movement. H before V, horizontal movement, vertical movement. So let's do this. Let's take these two vectors, U and V, and let's add them together. And then we want to draw a picture of what our resultant of what we're saying. So let's start with V. We're going to have -2, 1, and to that we are going to add 4, 3. So we're adding our horizontal movements, -2 plus 4, and then we're going to add our vertical movements, 1 plus 3, and that will give us 2, 4, and we write them with the arrow brackets because it's a vector. So my resulting vector, U plus V means go 2 to the right. Oops, I'm not using thought I was using a line tool and I was getting creative, and that doesn't work very well when you're not using a line tool. So we are going to go 2 to the right and then 4 up. There's the vectors. When we started out, if you want to take a look at the whole thing, we start out with this vector, -2, 1. And then to that, we added the vector 4, 3. And that would be my new vector. Boom! Look at that. Pretty cool. All right, let's just illustrate this one. Let's take -2u. So we're going to take vector u, because it says u right there, and we're going to multiply every part of that vector by a -2. So I don't like writing with red a whole bunch. It's a fun color, and I don't think it's just made just for general writing. I'd love to hear what you thought about that, but I don't think red is for general writing. It looks aggressive. So if we do -2, and we're going to make this one -2 times bigger, that's going to be 4 and -2. Boom. So my ending vector would be 4 to the right, 2 down. Because what we started with was 2 left, 1 up. My initial vector was 2 left, 1 up, and then I just flipped the opposite direction and 2 times longer. I knew it was going to be the opposite direction because it was negative, and I made its magnitude 2 times bigger. Oh no, we're going to do a whole bunch of this, and you know what? Who really cares? So pause the video, try it, and then start the video again. See if you got what I'm about to get. All right, let's see what you got. So I am going to do 3 times the vector -2, 1. And then we're going to do -2 times the vector 4, 3, and we're going to combine our results. So in this first vector, I am getting -6, 3. And I am going to subtract, I'm going to keep the minus on the outside for a minute. We're going to subtract 8, 6. So when we did negative, so we're going to do negative 6 minus 8. Negative 6 minus 8. That'll give me negative 14, because negative 6 minus 8. And then I'm going to do 3 minus 6, which is negative 3. Boom. Alrighty, so you can, of course, draw an illustration of that. So if we've got our grid, we're going to go 14 to the left, but only 3 down. And that was the sum of those two vectors. So, and a scalar of them. So we went 2 to the left, 1 up. And we went 4 to the right and 3 up. You know what? Let me move it. Going to pick off where we left off. So what we're doing is we're going this way, but we turn around because it's negative and we go that way. Boom. So if you got any questions about that last part visually, let me know, because it is a bit trickier. But instead of this vector, why is it this one? Because we made it a lot bigger and in the opposite direction because of the subtracting. Now we have something cool called unit vectors. Unit vectors have a magnitude of 1, just like the unit circle has a radius of 1. And normally when we define our unit vectors, we're going to have an I motion, which is horizontally, and a J motion, which is vertically. And usually when we write the I and the J, we write them very dark. We bold them. We bold the I and the J. We make them very dark to let everybody know, hey, we're talking about a vector here, pal. So if I gave you in component form 3, 4 for this vector, another way of writing this would be 3i, because we're moving 3 to the right, and then we are going 4 up. We are giving you 2 different vectors. I'm going to give you a horizontal vector and then a vertical vector. And then the vector we're really talking about is u. It is the sum of those 2 vectors. So if I said find 2v, the same rules that we just talked about apply. So we are going to take 2 and we are going to multiply it by the vector I, nice and bold, minus 3j. We like to do it bold because it's letting everybody know it's a vector. And I didn't write it as a vector. Well, you know, we really don't, I don't need to write them with this because it's not component form. So my resulting answer would be 2i minus 3j. No, it's not. 2i minus 6j. Wow, it's getting late when I'm doing this, everybody. Please forgive my arithmetic mistakes. If you think I've made a mistake on another thing, please let me know. Let's do B. So we're going to do 2u plus 3v. So we're going to do 2 times 2i plus 3 times I minus 3j. So we're going to multiply here. That gives us 4i plus 3i, let's pay attention this time, minus 9j. Combine our like terms. 4i's plus 3i is 7i minus 9j. Now order matters when I am subtracting, so we're going to start with v and we're going to subtract 3u. So v is I minus 3j minus 3 times vector u. So I minus 3j minus 6i. I minus 6i is negative 5i minus 3j. Boom. That wasn't so bad. I and j are just another way when we're using our unit vectors that we can write a vector from component form. Easy. So next when we come back, we're going to look at what the dot product is, and we're going to look at some properties of dot products, and we will finish up the videos. So I'll see you when I see you, and if you have questions, please let me know.